Assalamu alaikum. So in this video we are going to see about encoder, multiplexer and demultiplexer. So in last video we have seen about a decoder. The encoder is the opposite function of decoder. So the encoder is also a combinational logic circuit. The encoder is a combinational logic circuit that essentially performs the opposite function of decoder circuit. So it is the opposite function of decoder circuit. An encoder accepts a active level, that is 1. It accepts the active level on one of its input representing a digit, that is decimal or octal. So it accepts active level and it represents the decimal or octal digit and converted into a coded output, and it will be converted to coded output, that is a binary or BCD. Okay, so the process of converting from a familiar symbol of or number to a coded format is called encoding. So the process of converting form is called encoding. So see here, I have an input from 0 to 9. I have an input from 0 to 9. This is a decimal input. So this input, what is this input? For example, if we have 2 to the power 2, the output will be 2 to the power 2. The output will be 4 outputs, right? 2 to the power 3, 8 outputs. Then 2 to the power 4, 16 outputs. So see here I have 0 to 9. So it comes under 2 to the power 4. That's why the decimal inputs are 0 to 9. The output is A0, A1, A2 and A3. Fine. Okay. So see here. Now we can implement the logic circuit for the decimal BCD decoder. See here. I have a input 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And see here, the outputs are A0, A1, A2 and A3. So see, when it comes to 0, 0 is grounded, right? And about 0 is grounded, and about 1, the value is 0, 0, 0, 1. And 2, 0, 0, 1, 0 and 3. So this is the BCD code and this is the decimal code. And here we can see, you can easily say that the A0 will be connected with, see here, A0 will be connected with, 1 minute, A0 will be connected with 1, 2, 3, 4 and 5. The inputs are 1, 3, 5, 7 and 9. Okay, so A0 is connected with 5 inputs. So see here, you can see here the A0 connected with 1, the A0 connected with 3, the A0 connected with 5, okay, the A0 is connected with 7 and the A0 is connected with 9. Okay, so see here A0 is connected with 1 plus 3 plus 5 plus 7 plus 9. Next, A1. So the A1 is connected with 2, 3 and 6, 7. So 2, 3, 6, 9, 7. So see here 2, 3 and 7 and 6. Okay. Next about A2. So A2 A2 will be connected with 4, 5, 6, 7. So A2 will be connected to 4, 5 and 6 and 7. Finally, A3 is connected to 8 and 9. A3 is connected to 8 and 9. See 8, 9. Okay, fine. So this is decode. This is the circuit how we have to draw. If there is a 10, if there is a value 10, what is the binary digit of 10? 1, 0, 1, 0. So 1, 0, 1, 0. So A1. So the 10. For example, I have a value 10. I have a value 10. The value 10, input 10, right? Input 10 will be connected to A3 and also in A1, right? So it will be connected to A1, right? So if there is 11, 1, 0, 1, 1. So it will be connected to A3, A1 and A0. Okay. So this is the way we have to draw the logic circuit diagram for encoder. Okay. I think you all got it. Next we are going to see about multiplexer. A multiplexer is it will be called it as MUX. It's a device that accepts data from one of many input sources. It will accept data from one of many input sources for transmission over a common shared line. It will be transmission over the common shared line. To achieve this, the MUX has several data lines and single output. Several data lines. The data lines will be several, the output will be single output. Okay, single output along with the data selected input, which permits, so data selected input, serial inputs, okay, which permits digital data on any one of the input to be switched to output line. So this is like a switching device. This is like a switching device. For example, if there is a serial value 0, 0, D1 will be selected. D1 will be selected. If there is any the input is 0, 1, D2 will be input selected as D2. If there is 1, 0, the input selection is D2. If there is 1, 1, the input selection is D3. For example, if my value is 0, 0, so the output is D0. If it is D0, if it is 0, 1, the output will be 1, 0. So here the serial is on, right? The serial 0 is enable. So the enable value will be 1, right? So here it is 0, right? So the data, what is the D1? So the output will be D1. If there is 1, 0, the output will be D2. If there is 1, 1, the output will be D3, because both the inputs are 1. So the output will be D3. Okay. So see here. So y is equal to D0 S0 S1 naught S0. Similarly, the data input is D1. So D1 for D1 0, 1, right? So 0 S1 naught and S1, D2 S1 S1 naught, D3 S1 S0. Okay, so the Y, the output is the OR gate of D0, D1, D2 and D3. Fine. So this is multiplexer. And about demultiplexer, demultiplexer is the opposite operation of MUX, DMUX. Demultiplexer is the opposite operation of multiplexer. That is, its function is an electronic switches. It will be act as electronic switches to route the incoming data signal to one of the several output signals. So see here, the same. The output, this serial is two serial, S0 and S1, and the output is 1 because it is DMUX. The input is 1 and the output will be 4 outputs, Y0, Y1, Y2, Y3. So see here, so I have a one input, okay, I have one input D, and my serial is 0, 0, 0, 1, 1, 0. This is switch. It is like it will act as a switch, 1, 1. So if I put 0, 0, the output will be Y0. If I make it 0, 1, the output will be Y1, 1, 0, the output will be Y2, and 1, 1, the output will be Y3. So serial, so the two serial switches, and D value will be connected to Y0, Y1 and Y2, Y3. Okay. So see here, when I make a 0, 0, so Y0 will be the output. When I make 0, 1, the Y1 will be the output. 1, 0, Y2 will be the output, and for 1, 1, Y3 will be the output. Okay. So I think you all got it. So the chapter 5 is over, and in next video we'll see about chapter 6, inshallah. Thank you.